Okay, so welcome to Mole Island. This is a trick that I learned when I was in school, and it really helped with converting between molar mass and moles, particles and moles, and something new that you're going to be introduced to today, volume in moles. But the goal for today is you're going to learn what values are related to the mole. You know a couple of these already, but the new one will be volume. I'm going to teach you about Mole Island, and this is going to help you as far as converting between all of these values. So, again, just to reiterate, a mole is a gigantic number. Okay? So if you read some of these statistics, like 1 mole of dollar bills stacked one on top of another would reach the sun to Pluto 7.5 million times. That is just huge. Okay? To go with that, because 1 mole of an atom can actually fit in the palm of your hand, atoms therefore must be immensely tiny. Okay? So that's why we use this mole figure, so that we get to the point of dealing with enough of an element for us to actually see and work with. Alright? Again, the number of particles in a mole of something is always the same number. It's Avogadro's number. Okay? So we leave it at 6.022 times 10 to the 23rd, but there are some technically more decimals past that. But again, just to kind of show you how large this number is, we're familiar with thousands and millions and billions and maybe even trillions, but then you hit quadrillions, and then you still have 6 more numbers after that, which are even bigger. Okay? So this is a gigantic number that makes it so that we have a usable amount of something incredibly tiny. Okay, so there are 3 things that you're going to need to know related to the mole. We've talked about 2 of them already. That's these 2. Okay, molar mass comes off the periodic table. That value for each element on the periodic table is the mass of 1 mole of those atoms. Okay, we've talked about Avogadro's number. Right, so if you have a mole of copper, you have 6.022 times 10 to the 23rd copper atoms. The new one today is volume. Okay, so we use this because a lot of times we work with gases. Gases take up space, and even though some of the particles may be bigger, like a hydrogen gas molecule is going to be much smaller than a argon gas molecule. All right? Regardless of their size, regardless of the mass of the molecules, they always take up the same amount of volume. So a mole of any gaseous element will always take up 22.4 liters of volume. All right? Now, one stipulation to that is as temperature changes, volume changes. So this is only true at standard temperature, and pressure. That's what STP stands for. The standard temperature is 25 degrees Celsius, and the standard pressure is 1 atmosphere. Not a huge thing for you to be concerned with. It's just in case you ever run into a question where it says, you know, assume conditions are like this. That's what they're talking about. Okay? So we have these 3 relationships between a mole and something else. So we have a conversion factor for moles to liters, we have a conversion factor for moles to grams, and we have a conversion factor for moles to particles. So by the end of this, you should be able to bounce back and forth between any of those. You should also be able to go from something like, say, particles to volume. Okay? Or mass to particles. And so let's talk about Mole Island a little more, because that's going to give you a visual as far as how you could do something like this. Okay, so here's Mole Island. Mole Island is in the center. And the only way that you can get from, say, mass to particles is through Mole Island. Or the only way you can get from volume to particles is through Mole Island. The point of this picture is to drive home the point that where if you're doing conversions, say you have mass but you want to know what volume it is, you're going to have to go to moles first. We don't have a direct conversion from, say, mass to volume. We're going to have to convert to moles first. Okay, so if you're going from mass to mole, it'll be a one-step problem. But if you're going from, say, mass to volume, it's going to be a two-step problem. And we're going to set these up like conversions we've done before with dimensional analysis. So say you know the mass of something, and you want to get to the volume of it. What that's going to be formatted like is you're going to have blank grams of whatever you started with. You're going to put its molar mass in the bottom, and 1 mole on top, because molar mass is equal to moles, 1 mole. And then we're going to put 1 mole on the bottom to cancel that out over here. And we're going to put volume doesn't change based on the type of element, so just 22.4 liters. What this would do is grams are going to be canceled out by the grams in the molar mass here. Moles are going to get canceled out, leaving you with liters. Okay? So let's do some problems. Sorry, one step ahead of myself. This one I like just a tiny bit more than the last picture because it gives you the conversions on the lines. Okay, so to get from mass to mole, you're going to have to use 1 mole is equal to the molar mass. Now, molar mass is the one number that'll change because different elements have different masses. Okay, or if you are going moles to volume, your conversion is going to be 1 mole equals 22.4 liters. Now, where you put that in the parentheses depends on what you're trying to cancel out. And then the last one, your particle conversion, you're going to use Avogadro's number. And 1 mole equals 6.022 times 10 to the 23rd. Okay. Here's one more depiction of that same picture. And again, it has the conversion factors in there for you. So now let's apply it to a problem. So we're going to start out with some single step problems. How many moles in 14.9 grams of lithium? Okay, so I have 14.9 grams of lithium. Since I have grams, I need to know my molar mass of lithium, which is going to be 7 grams. And that's equal to 1 mole. Okay, so I'm going to grab my calculator here. 14.9 divided by 7, because the 7's on the bottom, and you get 2.13 moles of lithium. Okay. So next one, how many grams and 4.2 moles of sodium hydroxide? So 4.2 mole NaOH. This time, mole has to go on the bottom. Okay. And on top, I'm going to have my molar mass of sodium hydroxide, which is 20. Let me look that up really quick. Sodium is 23. Plus 16 plus 1. Which is 40 grams of NaOH. Alright, my moles are going to cancel, and I'm going to be left with 4.2 times 40, which is 168 grams of NaOH. Okay, and one more single conversion. If I have 345 grams of CuSO4. I need my molar mass for on the bottom. So I'm going to look up copper is 64 grams, sulfur's 32, 64 plus 32 plus 16 4 times. And I get 160 grams of CuSO4 and 1 mole. So I do 345 divided by 160 and I get 2.16 moles CuSO4. Okay. Alright, so using molar volume, you're going to use that 22.4 liters. Okay. So here I'm going to have 440 liters of O2, or oxygen gas. In this case, since we're not dealing with mass, that 2 doesn't matter. So I've got 22.4 liters on the bottom and 1 mole. My liters cancel out, which 440 divided by 22.4 is 19.6 moles. Okay, and then how many liters in 1.76 moles of nitrogen gas? So 1.67 moles. 1 mole on the bottom. 22.4 liters on top. And that is going to be multiplied, 1.76 times 22.4. 39.4 liters. Okay, now last one is a trickier one, and this is putting it all together. What mass is 34 liters of ammonia gas? So this is going to take 2 steps because I can't go straight from liters to mass. I have to go to liters to moles, then moles to mass. So 34 liters, ammonia gas is NH3. 22.4 liters, 1 mole. And then now to cancel out moles, that has to go on the bottom. I'm going to put the molar mass on top, which was 17. And now you can see that the liters cancel, the moles cancel, so now I just have to apply my math. So 34 divided by 22.4 times 17, which is 25.8 grams. All right. So, I'm hoping you are at the point now where you can do this on your own. If you need to, pause, go back, have the mole island sitting in front of you. Okay? But again, if you can email me your work and answers to these questions, I'll throw some extra credit your way.